So since today is about solving trig equations, we have to be really, really good at factoring. So I'm going to hit you with like easy to hard, regular factoring problems. And then I'm going to show you what if it was trig. All right, so like for example, x squared minus 1. Do you know how to factor that? I do. Do you? Ava, you got this? What is it? Yep. And it doesn't matter which order you do it in, but there has to be 1 minus and 1 plus. Does that make sense? So then, sine squared x minus 1 equals 0. It's amazing how kids are like, I have no idea how to factor that. It's the same thing. It just has the letters or the word sine in it. They do get trickier, but each time you want to set it equal to 0, that's huge, and then you want to look for what can factor out. All right, so this would be sine x and sine x, and a plus and a minus. We know that because this is negative, and then it has to be a 1 and a 1. All right, now that's factored, and that's great. But that's not the answer. The answer is, what is x? So at this point, you'd set this one and this one, but they're the same. So no sense in doing it twice. Equal to 0. Everybody do this, please. Sine x plus 1 equals 0. Why? Because you can set this part equal to 0 and that part equal to 0. You've been doing that since literally 7th grade. It didn't have trig in it, but when you had two things that were multiplied equal to 0, like x plus 1 and x plus 4, whenever you took pre-algebra, maybe they didn't have this till algebra. It's possible, but you knew that -4 worked and -1 worked. You set them equal to 0. You've done this forever. And there's your answer, and then x plus 4 equals 0. And there's your answer. Okay, so we set it equal to 0. And now, how do I solve this? Well, the first step is you look to add or subtract anything, because PEMDAS. I'm always trying to tell you why I'm doing stuff. It's because the order of operations, but backwards. You do any add or subtract that you can when you're solving equations. I can subtract 1. So sine x equals -1. How many of you had that before I said it? Good. Now, do you know that you can't draw a triangle with a hypotenuse that's the same? So this has to be a quadrantal. It'll be one of these 4 spots. Now, in the old days, I used to tell you to label all of the 4 spots because you weren't very good at this. But I think you're getting good enough that you know that sine is y, and then y must be -1. Do I really need to label this spot if y is -1? No, it doesn't have a -1 in it. And this spot doesn't have a -1 in it either. This has a -1, but it's the x, and this has a -1, and it's the y, so it's this spot. And is that 0 degrees? No. Is it pi over 2? No. Is it pi? No. What is it? 3 pi over 2 is the answer. So let's just look through this process. We have to know how to factor like normal things like this so that when they turn into trig like this, that we can still factor it like this. Then we have to know to set that equal to 0 like this. Then we know to subtract 1, and we get this. You got to know that there's another 1 here. You got to know it's y over r. Is there any, wonder why this test is hard for people? You see how many things you had to know just to get near the end? You had to know tons of crap. If you forget that sine is y over r, you're done. You can't do it. And then you have to pick from the 4 quadrantals, because, oh wait, you had to know that that can't make a triangle, with the hypotenuse being the same as a side. Hypotenuse has to be the biggest side, and that's not possible there. So then it had to be one of the quadrantals. Then you have to know what all 4 quadrantals are. And then, once you pick it, you got to know how to write the answer, not in degrees, but in radians. Wow. Think about how much you've learned since the beginning of the year. At the beginning of this year, you didn't know any of those things, except for the factoring, and some of you didn't know that. Yes?
If it's sine squared x minus 1, that would be a plus 1.
All right. So, wait a second here. So, I'm going to go back up to this. So, sine x plus...
It was sine x squared minus 1.
Oh, you got a very good point. Nice catch. Okay, so this says minus 1. So there is a plus 1 here, and the answer we did is all correct. But it isn't supposed to be plus and plus. Good catch. I'm impressed. That's supposed to be a minus, because we need a plus and a minus. You know, like I did before on this one. I can't believe nobody caught it till now. Nice catch. So this one actually has an answer, but we're not going to take a long time to do it. I'm just going to say if sine x minus 1 equals 0, I'm going to add 1 to both sides, and the minus 1 and the plus 1 cancel. Sine equals positive 1, and where is sine positive 1? Which of these is sine, which is the y? Where is y positive 1? I feel like it's that one. 0, 1, and it is. And so that one's pi over 2. So there was another answer. Very good catch. All right. So I'm going to go through a bunch more where there's like tricky factoring that kids have forgotten how to do, and then I'll show you how it's kind of like that in trig. So here's another kind of factoring. It even stumped me for a heartbeat. How the heck are you going to factor that? I did tell you, first thing you want to do is blah. And that would help a lot. There's a reason that the kid made the poster, because I say it all the time. If you can factor it, you should. And this hard problem, it's factoring, and that's why kids struggle in this class. That's why I wanted so bad for you to get really good at factoring, because they get tricky. Would you agree I said set it equal to 0, so we should subtract x. Now it'll equal 0. Now I know some of you are thinking divide by x. That wasn't a crazy idea, but you can't actually do that. If you divide both sides by x, you're introducing a new complication, and that's that x is not allowed to be 0. But x is allowed to be 0. So bottom line, you can't divide by x, but you can subtract x. And now, it's set equal to 0. I did say that, and I can rest on that one. You will always set it equal to 0. Always is almost, we almost never say always. But you can always set it equal to 0. Now what? Dominic was even gone yesterday. I bet he can factor it. Factor out an x. You got it. And if you don't know what he's talking about, they both have an x in them. So I can divide them both by x and take it out to the front. Of course, there's a minus in the middle. Bridger, what do you think is left when I divide this by x?
X squared.
Yep, and this one?
1.
Yep. I factored it, but I haven't factored it all the way yet. This part can be factored again. Now, do you get, if this was trig, this would just have like a trig function on it, like cosine x, and cosine x, and cosine x? It's the same, going to be the same exact idea as that. And now this part could equal 0, and what kind of an answer is this if it equals 0? Do you think that's going to be a triangle drawing kind of deal? No, so it must be a quadrantal. And this part will be cosine x plus 1 equals 0. Pretty easy to subtract 1. And you got cosine x equals negative 1, and that's going to be a quadrantal too. And then this one, cosine x minus 1 equals 0, cosine x equals 1. That's another quadrantal. Look at that, 3 different quadrantals. I'd like to do all 3 of those right now. Would you just take a second and figure out each of these is a quadrantal. Don't forget that cosine is not y. This is one quadrantal, this is a different quadrantal, this is a different quadrantal. Pause for a second. And pro tip, I think one of these has got 2 answers. And that means I think there's a total of 4 answers. I'm going to pause for a second, and in a moment, I'd love for you to see how many you got. If you got all 4, compare them with the kid next to you. If you got like 3 of them, see if they can show you where that one is that you missed. Okay, so in a second, you'll compare with the kid next to you. Okay, so cosine is 0 means that, well, remember, this is over what, and this is x over r, and the radius is always 1, so it's pretty much down to just cosine of x equals 0, so x must be 0. So if I want to find which one of these spots has x equal to 0, I think about this being x, and that spot's probably it then. So then it's 1, 0. No, that's not it. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Okay, I really was struggling on this one, so I just wrote them all out. And then I go, x is 0. So, which one of these has x is 0? Ooh, that one has x is 0. And this one has x is 0. So that's both answers. Pi over 2 for that one and 3 pi over 2 for that one. Raise your hand if you had those 2 answers. Okay, awesome. And then over here, cosine is negative 1, which really I can stop doing the radius thing. Cosine is just x. X is negative 1. That doesn't have any negatives in it. That doesn't have any negatives in it. Let's see if this is it. Negative 1, 0. Is that the spot where x is negative 1? Yes, it is. It's that spot, which is pi. And last but not least is this one. The x has to be 1. That's this spot right here. And so I know it's that one. So I know it's 0. So there are 4 answers. 0, pi, 3 pi over 2, and pi over 2. That's all 4 quadrantals. Hard to fathom, but we have problems that have 6 answers. There can be problems with 6 answers. So this one's got 4 answers, and it's 4 quadrantals. I know you're thinking there's no more quadrantals to even use, but sometimes you could have... This could be like sine. It doesn't have to be the same function. And all of a sudden, if it's got sine, then all of a sudden you could have a completely another set of like triangles that you have to draw. Anyway. All right, let me try one more weird factoring one. That's a lot like what we just did. All I want you to do this time is factor it. Sine of x to the third equals sine of x. Sorry, the 3 should be here. My bad. Sine cubed equals sine. Great. How do you always start when you're about to factor?
Get a 0.
Get it equal to 0. So what do I do?
U minus the sine x, right?
Correct. There, I set it equal to 0. Xavier, what do they both have in it? So you take that out. Now you don't have to show this part, but I'm gonna, just to make sure you understand how to get these numbers. You could just jump right to it. Liam, what do you think goes here?
Sine x plus 1.
It's a minus.
Oh.
So sine x minus 1. And wait, if I do sine times sine, I'm just going to get sine squared. I want sine cubed. So something's off. You're close. Rissy, what do you think it should be? Yes. To make to the third power, we need this one to be squared. Did anybody catch that? Only a few of you. All right. Do you get, if I take sine to the third and I divide it by sine, I get sine squared left. Okay. Then it factors again. Everybody give me the final 3 factors for this thing. Because sine squared minus 1, it factors. Sine plus 1, sine minus 1. Now, I'm not even going to make you finish this problem because we did one just like it 2 minutes ago. But the sine goes here. That one's there. And this one breaks into 2 parts. Sine x plus 1, sine x minus 1. Then it's equal to 0. That's important. It was up here and I dropped it. It equals 0. It equals 0. So then this must equal 0, and that's a quadrantal, because, you know, you can't draw a triangle with it equaling 0. This one equals 0, so you'll subtract 1 from both sides, and sine equals -1. And this one equals 0, so you'll add 1 to both sides, sine x equals 1. And look at that, it's the same kind of thing we just did a second ago. That's 1 quadrantal, that's a quadrantal, that might be 2 quadrantals. So you probably end up with all 4 quadrantals again. Okay, so, moral of the story. Here's what we started with. Do you get, we set it equal to 0 first by subtracting sine, and then we could factor it twice. All right, here's one more that stumped a whole bunch of people. And I get it. It's weird looking. Is it set equal to 0? Yes, it is. So we don't have to worry about that part. It's not normal factoring, but there's a GCF that can be factored out. Lux.
You can factor out sine x to get cos x plus 1 equals 0.
Yes. I'm gonna just show people how you got that. You factor out the sign, because look, they both have a sign. And then, if you really want to do it right, you go up here and put divide by sign, divide by sign. That's the thing you're factoring out. And this part is a 1 plus, that part's just going to cancel, and what's left? Cosine x. And then, this part can equal 0, and that part can equal 0. And then you'd finish it. But again, I don't want to waste too much time on practice problems here. I just wanted to show you how factoring just keeps coming up over and over, and I told you it would at the beginning of the year. And here's another verification that, yep, if there's only one thing that's a basic algebra thing, you gotta know factoring. Because in this next test, it's gonna be all about factoring. And then doing circle trig. Like from here, you gotta know sine x equals 0, and then how to do that. Oh, I guess it's over 1. Oh yeah, sine is y over r, you gotta know that. And then you got to know the quadrantals. Where is y 0? And then y is 0 here and here. So the answers would be 0 and pi for that part. Okay, pretty intense. So you got a partner for today, and you're going to work through the assignment. And it's not really, weirdly, an assignment that's due tomorrow like normal, because this is a continuation of that holiday we talked about before. So this is just time to work, and we're not going to actually have anything due tomorrow. All right, that's all I have for you. Except, you know what? Let's start the first problem. I know the first problem is weird on the Schoology quiz, so open up the Schoology quiz and let's do the first problem together, because it's weird and it's got one more thing on it that is really, really important. Okay, so everybody find that Schoology quiz, open it up, and here's the trick I want to remind you about. If I knew this side was 1 and this side was 8, do you remember how to find the third side in a right triangle? Because that's the first thing we got to do on this other problem. How do you find that third side? You go square root 8 squared, 64. 1 squared is 1. And am I on the longest side? No, so then I minus them. Okay, so then that third side would be the square root of 63. Do you remember how to find the third side in a right triangle? It's huge, it's a big deal. If I was going to make another top 20, that was like 20 more things that really handy to know. Being quick at finding the third side is a really big, important one. Yes, sir?
It's 3 root 7, right?
Ooh, I don't know. Square root of 63. Does 63 break up into?
And it breaks up into 9 and 7.
Oh, yeah. Good point. All right, awesome. Now, I've reminded you how to do that. Now let's actually do the first problem, and you'll see why we did that in just a second. All right, number 1. Xavier, would you please read it to me?
Sine equals 2 squared over 2. Or no,
Square root of 2?
yeah.
Over 2. All right, so everybody start by drawing this, and we did so many quadrantals, you might think that we are only doing quadrantals. Now, this is a normal one. We got to draw a triangle. So, first off, you got to ask yourself, is this sine thing positive or negative? Do you see any negatives? So the sign is positive. So that means that ASTC, you should know where to draw 2 triangles, wherever sign is positive. Well, sign is positive here, so that's one place. And the S, of course, sign is positive there. That's another place. So it must be not here, because sign would be negative. You with me so far? Graydon, can you tell me? If I, looking at this angle here, tell me the 2 sides we know.
Opposite the square root of 2 and hypotenuse is 2.
Yes. Do you know the third side by heart? But do you have a way to get it? We just practiced that. Once you know that third side, you'll go, oh, I know which triangle we're in. But first, take a second and go square root of. Now some of you are like, how do I square root of 2? Square root of 2 squared is just square root of 2 times the square root of 2. You should be able to do that. It's not that hard. Again, another top 20. I'm actually going to make another top 20, I think, because I've found enough of these little things like this, like squaring a square root. This should just be automatic. You should be able to go, square root of 2 squared, that's 2. Because the squaring takes off the square root, and it's just 2. So anyway, this squared is 4, that is 2, and then we subtract, and so then it's 4 minus 2. So this side is the square root of 2? Yes, it is. This side is the square root of 2. Do you get that that means we are in a certain kind of triangle? If these are both the same, what kind of triangle are we in? The 45. 45, 45, 90. And therefore, you should know what that angle is. You can't say 45. Got it memorized yet? What's 45 the same as? Pi over 4. Good. Why would you get it wrong if you just left it with that answer? Only because there's another answer. A bunch of pi over 4s. Is it 4 pi over 4 right there? 3 pi. Good. Do you get, we just found 2 angles, and that's what we wanted. The point is to figure out this angle. And we figured out it was this and that. Why was there 2 answers? Because you're supposed to give all the answers that are between 0 and 2 pi. This is going to keep coming up a million times. Give all the answers that are between 0. That means bigger than 0, so you never give negative answers. But less than 2 pi, because if you were ever going to say 2 pi, you should say 0, because they're the same thing. So this direction here is going to be on there, probably just at the top of the test, because you can't give negative answers, and you can't give answers that are 2 pi or bigger, because 2 pi would just be 0. All right. Cool. We're done with number 1. Well, how do you going to write that? There's no pi symbol. Pi/4, and always use lowercase, and then 3pi/4. I had tons of kids come up and ask me for help. I love that. I hope you do too. But ask yourself this before you come up. Did I set it equal to 0 yet? Then, can I figure out how to factor it? Because that's usually what's getting people. And if you can't figure out how to factor it, bring it up. I'll help you. But it's almost always the kid didn't set it equal to 0 yet, or the kid didn't factor it yet. And if you want help factoring, please ask. All right, that's all I got for you for today.